All right, second day of food energy, page 303, because we've already done scavengers and decomposers. The energy pyramid. Energy pyramid. Food chains and food webs show how energy is passed from one organism to another. Food chains / webs show energy, organism, arrow, another, zoop. However, they do not show the quantity of energy transferred, but not quantity. So, the words here match the words there. Food chains and food webs show how energy is passed, from one organism to another. That's the whole point of taking notes. You don't write the entire thing. You write symbols or arrows or colons that mean the same thing. So now I can say food chains and food webs show how energy passes from one organism to another, but it doesn't show the quantity that passes. When an animal consumes an organism, some of the energy it gains is used for life processes. Some energy used for life processes. Some energy is stored, some stored. And then, where is it? Some is lost to the environment as heat. Some lost. Only the energy stored in the body of an organism is passed on to another organism at the next trophic level. Okay? Stored, underline, arrow, passes on to next organism. So, think of like these butterflies and insects that are eating the plants. Some of their energy is used to grow and fly and reproduce. Some of their energy is lost to heat from being warm-bodied or from flying around and moving. But anything that they store in their body, anything that is their cells or the sugars or any of the stuff that makes up their body, when they get eaten, that was the stored stuff. That's what passes on to the next organism. An energy pyramid shows the availability of energy at each trophic level in an ecosystem. Okay, we already know that from our vocabulary term. Note that more energy is available for use at lower levels than at higher levels. Okay, more energy is available at lower levels than at higher levels. So if you take 100% of the energy at the producer level, only 10% goes up to the primary consumer level. 10% of that, or 1% total, is at the next level. And then 10% of that, or 0.1%, a tenth of a percent, is at this top level. Notice that it's a tenth smaller every time. Okay, let's see. Only about 10% of the energy from each level is passed on to the next higher level. About 10% passes each level. Recall that water and nutrients needed to sustain life are cycled through the environment and reused. Water and nutrients cycle. By contrast, energy that moves through an ecosystem is ultimately lost as heat and must be renewed. Energy lost as heat. Okay, so water goes through a water cycle and keeps getting used. Other nutrients, remember the cycles that we learned about last week? The carbon cycle, the oxygen cycle, the nitrogen cycle. All those things keep cycling around and getting reused and reused. But energy does not cycle that way. Energy eventually gets lost as heat. And some of that heat goes out through the atmosphere, out into space, and is lost forever. So that's why we need the sun to power producers. And then those producers feed the consumers, which feed the next consumers, which feed the highest level consumers, and as the energy gets smaller and smaller, there's nothing left. And when those things die, the scavengers and decomposers decompose their body, the nutrients that are in a cycle get reused, and the energy goes away as heat. And we have to get more back from the sun again, which powers the producers. Okay, this loss of energy from one trophic level to the next limits the number of organisms in a food chain. Number of organisms limited. For this reason, a food chain usually consists of only 3 or 4 species. Chain, about 3 to 4 species. Scavengers and decomposers are the final members of all food chains. Scavengers and decomposers equal final. Okay, what happens to energy that is not available to the next trophic level? All right, well, energy that is not available to the next trophic level is either energy that was used for life processes or energy that was lost as heat. If it's used for life processes, then it helps organisms grow and reproduce. If it's lost as heat, it is just lost forever, and that energy has to come back from the sun through the producers at the very first level. Okay, draw this pyramid on your piece of paper. 100% producers, 10% primary consumers, 1% secondary consumers, 0.1% or 0.1% third level consumers. It matches these numbers and these words right here. And then draw the pyramid around it. If it helps you, draw a little picture of grass and maybe a butterfly and maybe a mouse and a hawk or an owl. And that helps you see the different levels. All right, next page, 304. The energy pyramid and agriculture. Energy pyramid and agriculture. You are part of many food webs. You may be a primary consumer, a secondary consumer, or both. Okay, remember, a primary consumer eats the producers like the plants, the vegetables, the fruits. A secondary consumer eats the animals. So like when we eat beef or pork or chicken. Your food is supplied by agriculture. Our food supplied by agriculture. You are a primary consumer when you eat plants such as wheat, corn, rice, and soybeans, or products made from them. Eat plants equal primary consumer. You are plants are also fed to chickens, cattle, and hogs. Okay, so they are primary consumers. But you are a secondary consumer when you eat the animals or products made from them. So, eat animals equals secondary. And then quotes, the two little hashes, mean consumer, secondary consumer. Recall that the amount of energy available to an organism decreases at each higher trophic level. For example, suppose a quantity of corn supplies 30,000 kilocalories of energy. If the corn is fed to a cow, only about 10% of that energy, 3,000 kilocalories, would be available to a consumer eating beef from the cow. So only get 10% of energy. Okay? So if you eat the corn, there's a whole bunch of calories there, a bunch of energy for you. But if you decide to get a cheeseburger instead, you're only getting 10% of that energy. Sure, you love the taste of cheeseburgers, but you're only getting 1/10 of the energy you could have got if you had eaten the corn. That's why you're supposed to eat your fruits and vegetables. It's good for the planet and good for you. Okay, while 3,000 kilocalories would feed a human for 1 or 2 days, only 1 or 2 days, the 30,000 kilocalories in the corn would be enough to feed a person for 15 to 20 days. That's almost 2 to 3 weeks. So, 1 to 2 days versus corn, 15 to 20 days. Do you want to eat something and only have it last long enough for a day or two? Or do you want to be able to feed yourself for 2 to 3 weeks? Vegetables, fruits, producers, grasses, corn, all those things. Makes more sense. All right. Most animals are about as efficient at obtaining energy from plants as the cow. Okay, so what are they saying here? Most animals obtain energy, or they get energy, from the plants they're eating like a cow. In other words, most animals are only getting that 10% out of the plants. Pigs, for example, consume 7 kilograms or 15 pounds of grain and soy for every 1 kilogram or 2.2 pounds of meat they produce. Okay, let's look at those numbers. 7 kilograms to 1 kilogram. You have to feed a pig 7 kilograms of grain and soy just to get 1 kilogram of meat off them. So if you buy a pound of bacon at the store, you could have had 7 pounds. If you bought a pound of bacon at the store, you could have got 7 pounds of pancakes or 7 pounds of like soy milk or something like that. So that's kind of sounds wasteful, doesn't it? For these reasons, raising crops for food is more energy efficient than raising livestock for food. Crops, more energy efficient. greater than livestock. This also explains why secondary consumers, such as lions, hawks, and sharks, are not useful sources of food. Secondary, parentheses, lion, zoop, shark, an equal sign with a slash through it means not equal to food. So secondary consumers, such as lions and sharks, are not a good source of food because by the time you get up there, it's a waste of energy. Look at our pyramid again, right? Down here is the producers and the plants, vegetables and fruits. The primary, that's the things like the cows and the pigs. The secondary, now you're getting up into some of the predators. And then third level apex predators, that's like the lions and the hawks and the sharks. Instead of 100% of the energy, you're not even getting 10%, you're not getting 1%, you're getting 0.1%. That'd be like saying, hey, instead of $100, you're not getting $10, you're not even getting $1, you're getting a dime. Imagine somebody said you could get $100 by eating vegetables and fruits, or you could get only a dime for eating lion and shark. That's why nobody eats lion and shark and hawk and all these other animals. They are not a good source of food. Same thing over here, right? I could give you $100 and you could eat fruits and vegetables, or you only get $10 and you have to eat nothing but meat. Sounds delicious. I love cheeseburgers. I love bacon. But you're losing $90. That's a lot. All right, get your highlighter, get your red pen. Let's do our visual summary. Energy entering an ecosystem is passed from producers to primary consumers, then to secondary and third level consumers through food webs. Okay, highlight the main idea. I heard the word consumer. I heard food web. I heard producer. A food web is overlapping food chains. Okay, I heard moving of energy, right? Energy passes from producer to consumer. That is movement of energy. Food is energy. I heard producers, so produce and producers. I heard consumers, and consumers rely on producers. I heard food web, and here is that chain. When you go from a producer to a primary consumer to a secondary consumer, that is a food chain, so we highlight those. Decomposers break down dead organic matter, returning nutrients to the soil. Scavengers and decomposers, when things die, they decompose. It returns minerals and nutrients to the soil. Highlight those things. The energy pyramid shows that the amount of energy available decreases with each higher trophic level. There's the decrease with each higher trophic level. We're talking about the energy pyramid. We're talking about food chains and webs. And now it shows that the energy moves from one organism to another. How does it move? It gets a little bit less each time. In fact, 10% of what it was the previous level. Some energy is lost. Only 10% passes each level. Growing crops is generally a more efficient way of producing food energy for humans than raising livestock. Crops more energy efficient, greater than livestock. All right, now let's go back and let's do the red annotating. Energy moves, so we need to do things about energy moving. Which direction they go? Producers and consumers. Okay, consumer. Food web, that's what it's moving through. Producers. Food web, that's what it's moving through again. Which direction does it go, right? It moves in one direction. Up a food chain from producers to primary to secondary consumers. Okay. Decomposers are important because they return minerals and nutrients to the soil. Looking at the energy pyramid, we know that in food chains and webs, they show how energy moves from one organism to another. There's that energy movement again. And only 10% passes in each level, so that's how much is moving. Crops are more energy efficient than livestock. Very important, right? Because that ties into this whole thing about the pyramid and the trophic levels, which ties into the main idea of saying energy moves in one direction in ecosystems from producers to consumers. So if we as humans eat nothing but consumers, we're not getting all the energy we could get. We're wasting energy. We're wasting water. We're wasting soil. We're wasting crops. So we should try to get down to the lower trophic levels in the food that we eat so we can get more energy. In other words, we should eat more plants, fruits, and vegetables. All right, Good job persevering with a growth mindset. Obviously, you're going to go do your phase 3 connecting, your I know and I predict. And then you're going to write your phase 4 summary using the things that we highlighted and annotated. Okay, you know what to do. Go roar Wildcats.